Okay. So, guys, I was thinking on doing study groups with professors, so we can develop the material after class. I was thinking of doing study groups Thursdays and Fridays. I don't
Mm,
know if that's okay for you guys. I have right here right now like the hours I can do the study groups. I'm gonna put it in the chat, and you're gonna tell me, guys, which one is better for you. You can tell me I can be in the group one or can be in the group two. Of
huh?
course, it's not obligated to do that. It's for you for better understanding of the material.
Super.
We're gonna be posting the groups on the chat. You guys tell me if you can assist to group one, group two, group three, group four, or even if you cannot assist any of them, you can let me know which time you are available so we can manage to do something.
Super. Somebody asked me about the. I am bored to explain that the test on paper and the test online. Test on paper, by the way, is the due date is February 2nd. I sent by email through email the test on paper. No, you solve it home, you solve it at home, and send me back. And the due date is February 2nd. No, the most important in the written test is because you need to show me the word in detail. So you take one piece of paper, you solving the problem, and you send me back. How you send me? How you send me? No, 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 the same day. No, 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 no. Okay, okay. Don't worry, guys. You have time. Okay, I say with anticipation. You solving in detail, taka, 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 and send me back. Not the same day. Not the same day. Enough of day. But I don't want to explain detail now. In your moment, you can see. Okay? No, no, no. Relax, relax. Everything gonna be okay. Remember, I am where me and Cesar. Okay, this is very, 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 very complicated class and very, very intensive class. So we are here to help you in any problem. Uh-huh. Bueno, okay, okay. The student que have no communication with us are missing. So this student failed. But si you communicate with me any problem, you communicate with me any question about the homework, about the everything that you need to know. Okay, no problem. Test no because test is good question, Professor. I subscribe to YouTube. For example, this video, every video, I will post it in YouTube, no in Blackboard, in YouTube. YouTube is better. And the student can subscribe in my channel, have 5 extra points for each test, in any test, and 1 and 2 and 3 and 4 and 5. 5 extra points. Okay, okay, that's it. So everyone understand the idea for the CESAR study group. You take advantage of this. You are a student in the college. You are not kindergarten guy. When you see 0 in your grade, maybe you understand that you have to study. Okay, okay, okay. Let me see. See you see the whiteboard or no? Do you see whiteboard? Okay. The topic, the topic we discussed today. Well, today we discussed several topics, no? But the first topic is equation quadratic form. Let me explain in detail what is that. Suppose this equation is not quadratic. Last time we studied quadratic equation. But today we study another kind of equation that is called quadratic in form. Suppose this equation. Minus 2 x squared minus 1 equal to 0. Actually, it's not quadratic equation because the degree of this equation is 4. Degree is the higher exponent, is 4. Actually, it's polynomial equation, polynomial. And when this polynomial, because the exponent is a whole number, it's a polynomial, polynomial equation. It's a particular case que es also polynomial and quadratic form, but okay. I know que the number of solution is exactly the same. Solutions. The number of solutions is exactly the same of the degree. So when you finish this problem, we obtain 4 solutions. The reason is because it's polynomial and the degree is 4. But okay, the most important is que es quadratic form. Let me explain how you recognize que one equation is quadratic form. One is easy because we have two exponents, 2 and 4. And the relationship in between the exponent is que es twice. O sea, si you multiply 2 times 2 is 4, no? Entonces, this is when this situation happens. Not necessarily polynomial, because in another example that you see it's not polynomial, however, it's quadratic form. So we have two exponents, and the bigger exponent is twice the smaller exponent. That's it. Entonces, how you solve this? Well, you create substitution. Entonces, substitution classical in algebra, substitution we using always the letter U. That's the one to start WhatsApp group the chat. Guys, don't interrupt me, okay? Pay attention. Focusing on this. U is equal x squared. That you create a new auxiliary variable. Okay, I want to call you, another student call another letter. Okay, it's always the smaller exponent, no? So when you are doing the substitution, look, this is minus 2u because I define u is x squared. Okay. I try to avoid meshes now. And here we have 3 u squared, no? Because 4 power is twice this. So in this moment, this equation is a quadratic equation. And you solving this using exactly the same idea, quadratic formula maybe, that we are doing in the last class. Okay. After the class. Now pay attention my lecture. After the class, you try to set out the study group. Okay, A is 3, B is -2, and C is -1. And you apply the quadratic formula. Quadratic formula is minus B. I want to recall. Plus and minus, square root B squared, minus 4AC, divided by 2. And our specific example is B is -2, but the formula have a minus, so double minus become positive. Plus and minus, square root, -2 squared, minus 4, multiplication by 3, multiplication by -1. Let's see, divide everything by 2, by 3. Then let's do the operation inside the radical, according to the order of operation. This is 4, and this is plus. Be careful because it's double minus, no? Become plus 12. Because 4 times 3 times 1 is 12. So that is 16, and square root 16 is 4. Okay, so far we have 2 plus or minus 4 divided by 6, que is 2 times 3. Okay, I separate 2 pieces. 2 plus 4 over 6 using the positive sign, and 2 minus 4 over 6 using the negative sign. 2 plus 4 is 6, 6 divided by 6 is 1. And 2 minus 4 is -2 over 6, reducing lowest term is -1/3. And is the answer? No. This is not the answer because this is a u value. And remember, our original variable is x. But we almost finished because in that moment I split the paper in 2 parts. I put u equal 1 and u equal negative 1/3. But I know que u is x squared. Okay, at that moment, we have two new quadratic equations, pero super easy, que you can solve it using a square root method. Square root both sides, x is equal plus or minus 1. Square root both sides, x is equal, imaginary I plus or minus I, radical 1/3. Leave it like that, it's good. But much better is plus or minus I, radical 1 is 1, and radical 3, and rationalization to write more elegant, but this answer is correct. Rationalization denominator, entonces multiplication by radical 3. This is elementary algebra, plus or minus I, radical 3 over radical 3 times radical 3 is 3. And the solution set for this equation, the polynomial equation, but it's also quadratic form, is we have four solutions, no? Plus or minus 1, comma, plus or minus I, radical 3 over 3. End the story. Any question, guys? Do you understand the
Can
idea?
you do another example?
Absolutely. I have 1, 2, 3, 4 examples. Good. Let's see another example. See, you have no question, no? No? Let's see another equation. Okay, good. Okay, Frank. Another example. Suppose 5 x to the minus 2 minus 14 x to the minus 1 minus 3 equal to 0. Solving this equation. Well, this equation is no polynomial because poly is when the exponent is a whole number. Whole numbers. A whole number is no negative. Whole number is 0, 1, 2, 3, 4, 5. So no fraction, but only positive, increase 0. In this case, no polynomial. So this idea for the degree for solution is not valid. It's only valid when it's polynomial equation. But in this case, quadratic form, because the exponent here is negative 2, and another exponent is negative 1. Yeah, I know that negative 2 is twice negative 1. So we are doing again the substitution u equal u to the minus 1. You take always the smaller, the smaller and the absolute value, no? Okay, because I know that negative 2 is smaller than negative 1, but the absolute value, says 0 is equal minus 3 minus 14 u, because my definition was that u is u to the minus 1. Okay, by the way, negative exponent is reciprocal, no? Sorry, this is, carajo. This is no u, this is x. This is x. X, que es this, no? Que es equivalent to say 1 over x, reciprocal. But it's okay. Now here we have 5 u squared. And this equation is quadratic equation. And you solve it using, of course, the quadratic formula. A, B, C. A is 5, B is negative 14, and C is negative 3. Entonces minus B plus and minus square root B squared minus 4AC divided by 2A. Okay. Again, double sign, negative become positive. Plus and minus square root. Negative 14 square minus 4 multiplication by A, que es 5. Multiplication by C, que es negative 3. Divided by 2 times 5. Because A is 5. Entonces, negative 14 square, I put in my calculator, is 196. Minus, actually it's no minus. Minus, double minus become positive, no? This is 2060. 60. And when you adding this, it's 256. And square root 256 is 16. So far, we have 14 plus or minus 16 divided by 10. Because 2 times 5 is 10. As always, I separate in two pieces. Because I don't know, I like that way. 14 plus 16 over 10. And 14 minus 16 over 10. 14 and 16 is 30. Divided by 10 is 3. Remember, this is not the final answer. It's the U value. Remember, this, the idea was you take the original ugly equation, but you recognize que es quadratic form. You apply the substitution, and you magically convert to quadratic equation. You apply the quadratic formula, but the value that you get now is U value. But you transform the X because I know the relationship between X and X, X and U, sorry. Entonces, this is negative, negative 2, no? Over 10. So you reduce the lowest term, it's negative 1/5. Okay, now you split the paper. PI using U equal 3 and U equal negative 1/5. Okay, but I know that U, let me copy, U was reciprocal of X. Here, I copy again this idea that I create in the initial, the beginning, look. Here. Entonces, just flip it, reciprocal. Entonces, si U es equal 1 over X, es obvio que X es 1/3. Make sense or no? Reciprocal. Another point of view is, suppose U equal 3 and X equal 1 over X. And you apply cross multiplication, maybe, no? Cross multiplication. 3 times X is 3X. 1 times 1 is 1. Divided by 3 both sides. And you get the same idea. X equal 1/3. But one shortcut to do fast is flip it. The number is 3 over 1 because it's just 3. And when you flip it, it's 1/3. And here, exactly the same. You flip it, it's negative. The negative state 5. End the story. Solution set for this equation. Solution set, two solutions. 1/3 and negative 5. End the story. You get the idea? More clear now, miss?
Yes, thank you.
But I want to complicate more your life. Okay? Because I want to use it now fraction exponent. Obviously, it's not polynomial. It looks like similar to the radical equation that we studied last class. Suppose this equation, x raised to the 2/3, wow, fraction exponent, minus 7 x to the 1/3 plus 10 equal to 0. The first question is, this equation is quadratic in form or no? Yes or no? Help me. What do you think? What is the condition? Dice no. Andreina dice no. Another opinion. Well, it's no. Diane dice no. Never know. What is the condition to categorize to quadratic form? Es que we have two exponents. Look, we have two exponents. Safra dice no, professor, no. Okay, listen to me. You have two exponents. This exponent and this exponent. And the condition to be quadratic form is que the relationship between the exponent is twice. So if you take the smaller, of course, get 1/3, and multiplication by 2, you get 2/3. Entonces, ¿es quadratic form o no? Yes or no? Yeah, quadratic form, because the higher exponent is twice the smaller exponent. That's it. Entonces, we can transformation to quadratic equation. Okay. if you want to transform it, you create the famous substitution, u equals something. What do you think about u? What is the expression that you consider useful to you in a substitution? U equals something. U equal what? U equals something. Question mark. What is the expression that you consider? No idea? Totally lost? 1 over x? No. 1 over x? No. Remember, you have two expressions. Bam, bam. And you take u always like a contain smaller exponent. Because if you define this like a u, this would be u squared. This is the idea. This is the idea. Entonces, in conclusion, the shortcut, the mnemonic device, to remember, you take always the expression that contains a smaller exponent. And when you rewrite the equation, again, using the substitution, the auxiliary variable, this is u, and this is u squared. End the story. And this equation is quadratic equation. Quadratic equation. Elementary, super easy. Okay, in this case, we can use the quadratic formula. Of course we can, because A is 1, B is -7, and C is 10. But in my opinion, it's easier by factorization. Okay, remember, always we can apply quadratic formula, but my recommendation is when you have easy trinomial and you will be able to factorization, of course, don't hesitate because you solve it in 1 second, no? In this case, the combination is 5 and 2, no? 5 and 2, 5 times 2 is 10, and 5 plus 2 is 7, and negative both, no? That is the factorization. Done. So u equal 5, and u equal 2. Okay, you split the paper. My recommendation is you spend 2 seconds to see if it's possible or not the factorization. So you don't see it, no problem. You go directly to the formula. Okay, this is u, but I need x value. But x is x 1/3 equal 5. X 1/3 equal 2. Let me recall what means fraction exponent. Fraction exponent is like si you express it using radical notation, it's a cubic root. Like that. Okay, let me explain. Okay. Fraction notation. This exponent fraction have numerator and denominator, no? Numerator indicate the power, que es invisible one here. This one is this. And this 3 is the index of the root. In this case, is 3. And likewise, we have cubic root of x equal to. Okay. Entonces we are in front now in 2 radical equation. But this is easy because in order to remove the radical, you raise to the cubic power both sides. Cubic power, cubic power, cubic power, cubic power. Entonces x alone is equal 5 cubic, que es 5 times 5 times 5, que es 125. And x equal 2 times 2 times 2, que es 8. So the solution set is 125 and 8. End the story. Do you understand this or no? Sure? Okay. I am the guy that don't understand anything. Because you explained me, professor, in the last lecture, and when you solving the radical equation, you need to check in the solution into the original equation. And you don't do that. Why? The reason is that when you have cubic roots, fifth root, so when the index is odd number, never we have extraneous solution. We have problem. Well, sometimes yes, sometimes no. When you have a square root, 4 root, so when the index it's even, you need to check. When it's even. When it's odd, never. We have problem. Keep in mind this. Maybe when you study with me the function, the cubic root, you understand much better because it's a problem of the domain. But it's okay. So far, it's okay. But you remember mnemonic device, when there's odd number, no checking. When there's even number, mandatory checking. Okay? I have another very, 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 very hard and very, very complicated example in which you have even and you have to check. But so far, everyone follow me? Oh no?
Yes.
Good, very good. I like this class. I'm so proud. Remember, this class is given for me because the math department chairperson recommend me that class. This is amazing student. This is a student can have A and B in any math. That is the reason I am in charge. And also I have a auxiliary tutor. Okay, so you take advantage. We are doing the best for you. Okay, one more example, and you help me now. Suppose this example. Student emailed me. I am teaching now. Suppose this equation. Copy, please. Well, I have a question. Question number 1. This is quadratic form or no? Yes or no? Yes. Frank say yes. Why, Frank? What is the reason that you discover que es quadratic form? Because, what is the reason? Frank and Diane say que yes, because double exponent, very well, okay, super. Double exponent, 1/2 is twice 1/4. Entonces, what is my U value? What is my U substitution? What is my U? What is my U? What is my U? Okay, I have no idea. U. What is my U? What is my U substitution? U exactly 1/4. Danny Lustig say is professor is 1/4 because 1/2 is twice. So when you rewrite the equation using auxiliary U variable, this is 13U because I declare by definition, my own definition, que U is equal x to the 1/4 power, and it says twice, it says 2U squared. End the story. And this equation, nice. Miss, putting off the microphone. Eso, bueno, thank you. This equation is quadratic, and by factorization is possible, but it's too hard. Maybe we are using quadratic formula. A, B, C. A, B, C. A is 2, B is negative 13, and C is negative 7. Okay, minus B, plus or minus square root B squared minus 4AC divided by 2A. This is my classical quadratic formula. Plugging in into the formula the value. Entonces 13 is negative, double negative again become positive. We have negative 13 squared minus 4 times 2 que es 8 times negative 7. Divided by everything by 2 times 2. 2A. Entonces I put in my calculator. In my calculator, I put negative and make it zoom. I put in my calculator, look, we always doing that operation first because this is the order of the operation, no? Because the radical is considered like a parenthesis grouping symbol. Entonces, negative 13 squared is 169. Plus, why plus? Because double minus. This is 56. because the 4 times 2 is 8 times 7 is 56. Now you adding this is 225. And square root 225 is 15. Okay. And so far we have 13 plus or minus 15 divided by 4, no? By 4. Yes, by 4. Okay. As always, I like to separate into pieces. 13 plus 15 over 4. 13 minus 15 over 4. This is 28, no? Over 4 is 7. Okay. Now remember, this is not the final answer. This is U value. But almost we finish. Now, 13 minus 15 is negative 2, no? Negative 2 over 4, reduce and lowest term is negative 1/2. Okay, so now I split the paper. This is happening always. I split the paper for U equals 7. And for U equals negative 1/2. And remember, U was, the substitution was x to the 1/4, no? By the way, it's 4 root of x equals 7. And 4 root of x equals minus 1/2, no? I write in that way using radical notation, not in that way because I feel more comfortable with this. But we can write like that if you want. Because it's the same idea, no? You remember how you solve that? You raise to the 4th power because I want to clear that radical, or you raise to the 4th power here, and we have 7 times 7 times 7 times 7 4 times, que es x equal 2,401. Okay, and this is my first solution. And my second solution is raise again to the 4th power, both sides. X equal 1 over 16. And that's it. I finish. Exactly. Entonces, Lustig say, we will need to check in. Of course, we'll need to check in. Why we need to check in? What is the reason? Aha, because it's even. Super. Because it's even. Let's do it, guys. The checking part, extremely important. Let me check in for, okay, share person, send me, okay. I am teaching now, sorry. X equal 2401. So in order to check in, I come back to the beginning. Okay, beginning. Okay, beginning is this expression. Look. Yeah, I replace x for this number one by one. And verification, que es true statement or no? Remember, the original is 2x to the 1 over 4 minus 13, x to the 1 half, sorry, here. 1 over 4 here, minus 7. For me, it's much better express it in that way. Look. So 2401 raised to the 1/2 is that part. Minus 13, 2401 raised to the 1 over 4. Minus 7 should be 0. Yeah, I want to check this. I claim this statement is true or not. I don't know. Okay, one fantastic way, in my opinion, is right like that. This is a square root. And it's a 4 root. Either way, guy, the student can prefer radical notation. I prefer solving in that way, no? And this is a moment, can you put in the calculator, square root 2,401 and 4 root 2,401. Well, where I come from? 2,401. What's the multiplication? 7 times 7 times 7 times 7. It's not necessary calculator because the square root usually by couple. 1 7 and another 7, entonces 49. Now, the answer of this, well, you put it here or calculator, is 2 times 49. Minus 13, and this is 4 root, and 4 root you take the 4 7, and the answer is just 7. minus 7 equal to 0. Okay, your multiplication is 98. Your multiplication is 91 minus 7. It's obvious it's true because 91 and 97, you add in the negative, guys. 98, for example, minus 98 is 0. Super. 0 equals 0. Super true. Entonces, I prove que the solution 2401 is perfect solution. Let's see what happened with the second case, 1 over 16. So you need to check it both. Okay, I know it's too long. Okay, but this is not the point. It's too long, but it's no big deal. Okay, so let's checking for x equal 1 over 16. One is 2 times 1 over 16 raised to the 1/2, que es the square root, minus 13, 1 over 16 raised to the 1 over 4, que es 4 root, minus 7 should be 0. I claim this statement because I am not sure of it's true. Okay, so you feel more comfortable, you write like that. Okay, it's a fraction, but don't worry because I know the property. When you have a fraction, you find the square root of the numerator and the square root of the denominator, but the numerator is 1 and the square root 1 is 1. Entonces, basically 2, 1 over 4 because it's a square root. Minus 13 and 4 root 16 is 4. This is 1 over 4. 1 over 4, no, 1/2, 1/2, 1/2, 1/2. Because square root 1 over 16, 16 is square root 1 over square root 4 root, sorry, 4 root, carajo, is 1 over 2. Because 4 root of 16 is 2, because 2 times 2 times 2 times 2, 4 times is 16. Entonces, this is 1/2 minus 7 equal to 0. Okay, this is 1/2. It's obvious, reduce here. This is 13 over 2 minus 7 equal to 0. Okay. Let's combine, for example, in this case, much better combine the fraction que contain the same denominator. Entonces, 1 minus 13 is minus 12, ¿no? Over 2, que es 6. Entonces, minus 6, minus 7. Wow, es negative 13, no 0. Entonces, this is completed false statement. That means que the solution 1 over 16 is not valid. It's totally extraneous solution. And so you write the final answer, the solution for this problem is just solution set 2401. It's the only solution that this equation has. Any question? Confusing? Clear? Complicated? Clear? Okay, very well. Okay, guys, this I promise. In the review packet, we go over again to this. I promise in the test you see at least one question que is quadratic form. Okay, let's move on to another topic, important, super important, and confusing topic is about the equations. No. The test, Safra, never multiple choice. You have to show me the word in detail. Never multiple choice. But you have time. Equation and inequality. Remember, the test is not the same day. I send to you, and you have 1, 2, 3. I don't know exactly, but I give you enough time. Okay, you're working on the test. And when you Before the due date, you send it to me. Okay. Entonces, equation and inequality involving, o sea, que incluye involving, okay, involving absolute value. Absolute value. Okay. Let me recall absolute value. Absolute value, the symbolic way to indicate absolute value is like that. Absolute value 3 is 3. Absolute value negative 3 is also 3. Why absolute value is always positive? Because the geometric interpretation for the absolute value is, suppose this line represents all real number. 0 here in the middle. 1, 2, 3. 1, 2, and negative 3. Okay, absolute value represent this time from 0 to any number. So this segment is 1, 2, and 3 units. This time is 3. Absolute value negative 3 is also distance. It's the distance from 0 again to negative 3, because the distance is the same distance as 3. Okay? This is the interpretation absolute value. It's distance. Okay, it's a step 1, 2, and 3 steps. And the other direction exactly the same. 1, 2, and 3 steps. And the distance, when you talk about distance, is always positive quantity, because the distance from Haunted to Hialeah is supposed, hypothetically, 20 miles, and the distance from Hialeah to Haunted is exactly the same. It's 20 miles, no negative 20 miles. It has no sense to talk about negative distance. Okay? Distance is always positive quantity. Entonces, suppose that we have this equation, elementary kindergarten equation, absolute value x equal 3. Bueno, professor, according to the previous explanation, this is equivalent. This symbol indicates equivalent. That two things in mathematics get different form, but it's the same. To say that x equal 3 or x equal negative 3. Two solutions. So I take advantage of this idea. So the idea is, look, let me show you in detail. What is the mnemonic device? To remember this. Suppose you have one equation like that. Absolute value, any expression, any indicate expression, algebraic expression equal, suppose 10. This is equivalent. You break it down in two equations. You copy the any equal 10, and you copy the any equal negative 10. And you, if you want, connecting by or is, is this and this together, no? And you solve in this equation, and you solve in this equation. Okay, this is the idea for the equation can involve absolute value. I bring for you 1, 2, 3, 4, 5 examples. The first example, absolute value, 2x plus 1 equal 7. Okay. Okay, I promise in the test you see one question exactly like that. So immediately you copy 2x plus 1 2 times. It's expression inside the absolute value, but without bar. And you enforce it to be equal 7 and negative 7. And you solve in both equations. It's a linear equation, super easy. And that's it. And the solution is this and this. And don't need to check it. No. Checking only in the radical equation. Entonces es 2x is equal to 7 minus 1, que is 6, divided by 2, divided by 2, divided by 2, x is equal to 3. This is my first solution. My second solution is 2x is equal to minus 7 minus 1, que is negative 8, divided by 2, is negative 4. End the story. Solution set for this equation is positive 3 and negative 4. Remember, when you write solution set, you separate the element by comma, and the order is not important. Suppose another student write like that, minus 4, 3 is the same idea, right? The order is not important. It's the same solution set. Any question? Easy. Come on, guy. Are you bored? Are you there? Participation. Do you understand? You follow me? Confusing? Andreina, I say clear. Okay, Andreina, you always help me, remember? Okay, Safra. Yes. Super. Let me complicate a little bit. Suppose this example. Actual value x plus 3 plus 5 equal to. Suppose in the test I put something like that. It's a 5. Entonces, it's not ready to apply the idea. Because to apply the idea that I explained before, you need to isolate the actual value. When you isolate, you move 5 to the other side. 12 minus 5 gets 7. Because in this moment, are you ready to apply the idea? You copy now the expression inside the brackets x plus 3 equals 7, and the expression x plus 3 equals minus 7. And solve it both. This is x equal 7 minus 3 get 4. X equal minus 7 minus 3 gets negative 10. I appreciate so much that when you solve any problem, the final answer you enclose in the box to indicate the final answer. Okay, entonces I am a teacher, entonces I want to emphasize that the solution set is for a negative 10. Not necessarily you need to express it like that. See, you, for example, that you leave it like that, one box and another box, for me is fantastic. Okay? Clear? But I want to complicate a little bit more. Yeah, crystal clear, okay. I want to complicate a little bit. Look, suppose this. Absolute value. 5x minus 3 equal negative 4. Wow. What the hell is that? Okay, this is impossible. This is stupid. This is impossible. Why is impossible? Because I explained to you the actual value represents distance, and distance never is negative. And when this situation happens, this is impossible. Okay, this is completely contradiction, and this is no solution. Okay, entonces, no, when you have, for example, it's easy because when the right-hand side is negative, it's no solution. Because this equation is a contradiction. Because I know the actual value represents distance, and distance is always positive. Entonces I put negative. No, it's impossible, right? But not always is obvious. Suppose one example like that. X, actual value x plus 3 plus 10 equals 7. And you say solve this equation in the test. What should I do? Well, you isolate first the actual value. I move 10 to the right-hand side. 7 minus 10 is negative 3. Entonces, in that moment, you say, wow, right-hand side negative, no solution. Okay? No solution. Okay? Super clear? Okay, but this is the only particular, no, we have another particular special case in which the right-hand side is 0. Suppose 7x minus 3 equal to 0. What means equal to 0? Okay, we have no distance. See, we have no distance and 0. Suppose I want to apply the classical idea that you separate positive and negative. So you remove the bar. Okay, and you put 0, but 0 positive and 0 negative. What the hell? 0 have no sign. What is the idea that you are doing, professor? 0 is 0 without sign. So this is completely wrong. So 0 is just 0 without signs. 0 have no sign. Therefore, you have only one equation. So when it's 0, we have only one solution. que es 7x equal 3 divided by 7 both sides, x equal 3 over 7. End the story. Solution set, only one. 3 over 7. Entonces we can conclude que the equation que contain absolute value, we have three possibilities. Absolute value, any expression, is equal right-hand side. See, the right-hand side is positive number. We have two solutions. Keep in mind this, because we can separate into equations and you solve them both. See, the right-hand side is negative, no solution. And see, the right-hand side is 0, only one. One solution. End the story. What solution? You only remove the bar, any equals 0, and you solve this equation. In this case. In this case, it's completely contradiction, no solution. In this case, yes, it's a regular case. Okay? Any question? Any question? Is clear? No. You say no or more. Okay. And no. Okay. Let me now complicate more your life. Because equation is relatively easy. I understand very well, Professor, the equation. Let's move on to inequality. Let me try to explain the theoretical idea for the inequality. Suppose absolute value x less than, suppose 3. And absolute value x greater than 3. Let me explain that this is completely different to this. Okay, let me try to understand geometrically. This is my famous or real number line. Infinity positive, infinity negative. This is 0 in the middle. 1, 2, 3. 1, 2, and 3. Okay, the solution for this inequality, when there's less than case, is that part. Look, let me show you in blue color. Okay, it's the interval in between -3 and +3. So the solution for this part is from -3 to +3. Remember, the inequality solution is not one value, it's a bunch of values, the interval. But this interval contains two pieces. And make sense like this, no? Because the distance from 0 to 3 is less than 3. Entonces 1 is 2, is -1, is -2, and the value in between, because it's all real numbers, it's in between -3 and +3. Do you see this or no? Yes or no? Confusing or clear? Okay, entonces 1, one piece. One piece. So basically, one piece means one interval. However, this case gets greater than is when the distance from 0 to any number is bigger than 3, is that piece and that piece. Because there's a number too farther than 3. Maybe 4, maybe 5, maybe 6, maybe 7, or maybe -4, or maybe -5, or maybe -6, or -7. So the solution for that part is not one piece, it's two pieces. It's from -infinity, comma 3, comma -3, que is this piece. Look. Union, because it's both, from 3 to +infinity. Basically, the solution, when you're solving inequality and the answer is greater than, and of course, inequality can involve being the absolute value, no? Is 2 pieces. 2 pieces interval. Are you clear? Do you understand or no? This is theoretical part. Theoretical. I bring now 1, 2, 3, 4, 5, 6, 7 example. Okay, and when you feel comfortable, they are no absolutely. Yeah, okay. Do you understand this? Let's go to example. Theoretical part is clear. Let's apply the example now. Suppose absolute value 2x plus 1 less than 7. Ooh, immediately I recognize less than. Therefore, we have 1 piece, no 2. Okay, entonces, what is the equivalent idea? Well, the equivalent idea, you copy the expression inside the actual value, but without bar, no bar, and this is less than 7 and greater than -7. And you convert this inequality in another inequality que es compound inequality. Pero in this typical format. And the recipe is okay. It's similar to we are doing in intermediate algebra. Subtracting 1, because my goal is solve for x. It's -8. Break down to x. This is cancelled. And this is 6. Finally, divided by 2. Entonces we have -4. Okay, and always, okay, this is perfect. However, in the test, in any question, I specification clear, because the final answer is always expressed in interval notation. Interval notation. So in interval notation is parenthesis -4, 3. Remember, when you have no equal, it's parenthesis, you have equal here, so suppose hypothetical, no? It's bracket. I suppose you remember very well this idea. Okay. Let's clear this first example. Okay, let's do one example that include greater than. Easy. Of course, Andreina. Okay, suppose another example is absolute value. Look at that. Absolute value x plus 3 plus 5 greater than or equal 12. Entonces, immediately you see greater than, I expect 2 solutions, 2 pieces. So one solution can contain 2 pieces. Okay, just first of all, you isolate the actual value is greater than 12 minus 5, okay, 7. And so far I have x plus 3 is greater than or equal to 7. Okay, super. Now you immediately separate between one compound inequality again. Compound inequality. But this compound inequality contains 2 pieces. So I copy x plus 3 without bar. X plus 3 you copy 2 times without bar. And this is greater than or equal 7. Exactly the same. But less than or equal -7. It's in another direction. And you connect in both inequality because it's compound by or always. Because the solution satisfies this condition or this condition, both. And you solving this inequality separately. Is x greater than or equal 7 minus 3, 4. Okay, I'll leave it like that for a moment. This is one piece. And the second piece is x less than or equal -7 minus 3, okay, minus 10. And that's it, no. It's always like a compound inequality solution in which you finish the problem graphically. So this is, I put in my ordinary number line. Okay, something like that. Infinity, negative infinity. Okay, this is 0 in the middle. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, and negative 10. Okay. Okay, let's do in that part first. That part is greater than or equal 4. It's a bracket here, bracket, because include 4, including the endpoint 4. And to the right, no? Makes sense to get to the right because greater than. And it's continue forever in that direction. And negative 10 here, including negative 10 is equal, bracket again, but in the opposite direction because it's less than. Okay, so the blue part represent the solution, but graphically. I want the solution expressed in interval notation. So in interval notation, two pieces is from negative infinity, comma, negative 10 bracket, union, bracket 4, comma, infinity. End the story. This is my beautiful final answer. Any question? Do you need more example or it's clear? Everything is clear.
Can you do another example, please?
Don't worry. Be happy. Another example for you. Don't worry because in the review packet, we go over again into this, no? But okay, she needs another example. Actual value 3x minus 1 less than or equal 11. Entonces immediately, wow, it's less than, probably. And less than is one piece or two piece? What do you think? One piece or two piece? When you finish this, we have 2 or 1?
2 piece.
No, 1. Okay, only 1. Andreina is, okay, less than 1. Because it's near and greater than is far. It's 2. Keep in mind this. Do you understand very well this sketch or no? I erase or no? I erase, no? Let me see if I erase. Do you understand very well this sketch? Okay, when it's greater than, it's the green part. When it's greater than, it's the green part. And green part is 2 pieces. Oh, you understand? Okay? Okay, super. Okay, then in this case, you have only 1, no? Only 1. So what is the rule? When you copy 3x minus 1, only 1 time is in between 11 and negative 11. So you copy that number, 11 positive and negative 11. And the expression inside without bar. And you have in that moment compound inequality. And the rest is okay. Similar to we are doing intermediate algebra. You adding 1, adding 1, adding 1. This is negative 10. Bring down 3x. This is 0. And this is 12. Divided by 3. Divided by 3. Divided by 3. Well, so we have negative 10 over 3. Leave it like that. Negative 10 over 3. Less than or equal x. Less than or equal 4, no? Because 12 divided by 3 is 4. Express it in interval notation, because one piece, one interval only is bracket. Negative 10 over 3, comma 4. End the story, guys. End the story, guys. No more. Question. Question. No? No? Okay. Okay. Okay, no. Okay. Just we go. Remember, guys, this subject is too fast. Too intensive. Go back. Go back a second. Go back a second. Go back. Go back to what part? Here. What part you want, Vance? Come on, guys. I don't understand very well. What do you want? Never mind. Okay, never mind. Okay, never mind. Okay. Okay, okay. Now we start new topic. Remember, can we quick 5-minute break? No, no. No break. No break. 5-minute break. No, no. 5-minute break is no. 5-minute break I give you in the last moment. So we finish in no and 11:10. No, we finish 11:05. Okay. So this is the break is in the last moment. Okay. So the next topic is the definitions of functions. Very important. Functions and relations. And mathematics, of course. Function and relation. Very important. I introduce the next topic. Okay, let me try to explain relation. Well, relation is intuitive idea that we are doing every day. When you relate, so we have two sets. Suppose that you go to the supermarket and you ask for the how much it is. So you try to associate the thing that you want or the items that you want to buy and its price. So it's two set. We have two set. And the set, remember, it's the collection of the object. Maybe it's item, product, another set is a price, it's a number. There's $10, $15. You have two sets. Let me put an example to understand. Suppose that I have one class, MAC1106. It's a hypothetical class, no? Short class. And the first set is the students. Let me call, normally in mathematics, the set is called using capital letter. Capital X is a set formed by Sally, is a student. Paul is another student. King is another student. And Luis is another student. Okay, short class, only 4 students. This is the first set. Okay, the first set is normally called a domain. And we have another set. Okay, is the potential grade, because I want to associate when the Sally, Paul, King, and Luis finish MAC1106, I need to assign one grade, A, B, C, D, F. So the potential grade is A, B, C, D, and F. No E, no W, no, it's not grade. Well, W is yes. This set is range. Now let me try to associate this set. The relation is association. Relation. And the symbolic way to indicate relation in mathematics is using like ordered pairs. And you separate by comma. For example, Sally. Suppose que Sally, comma A. Oh, and the first component, I put the element in the domain, que es students, Sally, the name of the student. And in the second component, I put the grade associated with the Sally. And separate by comma. Another element of the relation, so the element of the relation is expressed using two, so the order pair, two components. Paul, suppose que es B. King, suppose que es B again. And Luis is A. Okay? This is the way a mathematical to represent relation. Relation is association between two sets. And normally, you define one set like a domain, is the first one, okay? And the second set is a range que is associated with each element in the domain. This is the idea for the relation, super easy, super straightforward. And not necessarily you can write like that, but you can write a relation using formulas, using graphic, using arrow diagram. We see it several times, but this is the most elementary, using ordered pairs. Now let's move on to the function. Function is more sophisticated relation. Functions is also relation, but it's a special relation. What is the formal definition of the function? Okay, by the way, is very, very confusing. At least for me, it's confusing. Well, function is a relation. It's a relation such that each value in domain, remember the domain is the name of the first set, is associated with only one and this is the most important part, only one value in the range. Okay? Let me try to translate in English, in common English, this idea. Suppose that you have, for example, one-to-one relation. When a one-to-one relation is, for example, x1, you associate with the y1. x2, you associate with the y2. So one-to-one. So one husband have one wife. Okay? Suppose many to one. Suppose x1 is associated with the y1. x2 is associated with the same. And suppose one to many. Suppose that x1 is associated with the y1 and also with the y2. Okay? This is the possibility. Entonces, what is the function and what is not function? What idea is a contradiction with the idea of the only one value in the range? Well, in this case, each value is associated with the only one. So this is perfect. This is a function. Yes, it is a function. In this case, well, each value in the domain is associated with the only one. In this case, yes. Yes or no? It is. Because the most important thing is that you have only one. For each x, you have only one. This is completely wrong. This is no function. It is no function because you associate each value, in this case only one, with two. Okay? This is super contradiction for the function. Do you understand the idea or no? Or it's confusing? Or you need the break? Clear a little bit. Okay, let's see. Suppose that we have hypothetical example. Suppose capital X is the domain. Okay, in this case 1, 2, 3, 4. No student, no, it's just number. This is domain. Range, capital Y, is letter A, B, C, D. Entonces ahí state different relations, and you determine, please, si this relation is a function or no. For example, relation 1. Relation 1 is 1, A. Remember, association, domain, and one element in the range, 1, A, 2, B, 3, C, 4, D. Okay, this is one relation. Our problem is determine yes or no is a function. Relation 2. Relation 2 is 1, A again, repetition. 2, B, repetition. 3, B, no repetition. So R1 is a function. Okay, Lustig say yes, professor. 3, B, and 4, A. And relation 3 is 1, A, again repetition. 2, B, again repetition. 2, C, no repetition, and 3, D. Okay, super. And 3, D. Lustig say that the second is also function. We have repetition B, pero no repetition X. Entonces R3 is no function. Excellent. And this is no. Do you get the idea? Do you get the idea? Yes. Everyone understand very well definition of the function? It's a little bit confusing, at least for me. Okay, super. Very well. Okay, guys. One possibility to identify it's a function when the graph is given, well, sometimes it's not given in that way using set notation. No. Sometimes it's given, for example, determine or identify the graph of the function. So one graph is given, suppose. Suppose 4 graph. Suppose that the first one is a parabola like that. I don't care. The formula is not important now. Only the shape. The second is a cubic parabola. The third one is this, que es also parabola, pero es horizontal parabola. And the last one is suppose que es a circle, like that. Entonces, looking the graph, I need to determine if this graph corresponds with the function or no. Entonces, I propose you apply one test, que es called vertical line test. Vertical line test. And this test allows us determine if the graph corresponds with the function or not. And this is easy because you are doing hypothetical vertical line. See this vertical line cross in only one point, like that, or like that, or like that, it's a function. Yes, pass the test. And when it cross in 2 points, or more than 2 points, in this case no cross, it's no function. No function. Super easy. That the vertical line test allows us study any graph and determine if it's a function or not. You apply hypothetical vertical line test in arbitrary point. Sometimes don't touch the graph, but sometimes touch. Si touch in 1 point is a function. Si touch in 2, 3, 4, 5, more than 1 is obvious no function. Clear? Clear the idea for the vertical line test? I promise. In one moment, we use it, yeah. We use it. Okay. So the most important moment in today is this topic. It's a function notation. Function notation. Function notation. Okay, we introduce now one useful notation can help me to understand much better the functions. Function notation. Function notation is both, well, actually we have two variables. We have x and we have y. I suppose that x is independent variable, independent variable, and y no, y is dependent. And the relationship between, we can do graphically set notation many ways, but the super important, in my opinion, useful way is using function notation. Function notation is something like that. Y is equal f of x. And we can read like that, f of x. F is the name of the function. What is the typical name that we're using in this subject? When we're using F, we're using G, we're using H, we're using P, we're using M. And the other chapter, we're using another function that, for example, the name is LOG, LM. Okay, normally we're using 1 letter, 2 letter, or 3 letter. No too long. Maria, no, there's no name of the function. And this is equivalent. So you replace y is equal f of x. These parentheses do not indicate multiplication. So suppose this is totally stupid way. For example, you have x plus 1. You cannot apply distributive property here. No. This is completely wrong. F of x plus f and 1. This is completely wrong. Because these parentheses do not indicate multiplication, indicate that this argument that belongs to the domain is plugging in inside the function f that you define the expression. And it's super useful to understand the thing that we are discussing in not today, the next time, que is a transformation, symmetry, etc. Let me put arbitrary example. Suppose f of x is given in the test. Is equal x plus 6 over 2x plus 3. This is a hypothetical example. And you, for example, plugging in here number, another variable, combination number and variable, that according to my intention to explain something. For example, you have learned to. Wow, it's easy. You replace x for 2. This is 2 plus 6 over 2 times 2 plus 3. 2 plus 6 is 8. 2 times 2 is 4. And 4 plus 2 is 7. The answer is 8 over 7. Okay? This is one super elementary idea. But not always you plug in here number. You plug in maybe number and variable. Suppose a plus 2. Okay, it's the same. You replace x for a plus 2. A plus 2. Hey, noise. Noise and music. No, please. Hey. What's going on? A plus 2 plus 6 over 2 times a plus 2 plus 3. So the thing I did was replace x for a plus 2. And the rest is, a little bit reduce transformation in one nice and countable. This is 8 plus 8 plus 2 plus 6 is 8, and you apply here distributive property to 8 plus 4 plus 3. So it's 8 plus 8 over 2a plus 7. Here's the answer for this. Okay. Wow. Today is the day que email me. Everyone email me. Oh, and that's it, no? No. Okay, I promise in your moment, Thursday, maybe for sure, no? Thursday, we study one thing is called symmetry. To testing the symmetry of the function. So to testing the symmetry, we have two kinds of symmetry, no? When you want to flip it, symmetry will respect the y-axis, and symmetry will respect the x-axis. Entonces, the formula for the symmetry is, for example, you replace x for negative x. So you want to testing the symmetry with respect the y-axis. Okay, so I want to prove que our function is symmetry. So we continue working with the same. No? The same is f of x. The original f of x was x plus 6 over 2x plus 3. I want to test in the symmetry. So you replace x for negative x. Entonces es minus x plus 6 minus 2x plus 3. Entonces we compare this and this, que is completely different, of course. Entonces no symmetry. Suppose another example. Suppose g of x is equal x squared. It's the classical parabola, no? The parabola look like that, no? This is the y equal x squared, or g of x equal x squared. Suppose I want to test in the symmetry. Okay, you replace x for negative x. Yeah, I know. Okay, this is negative 1 squared and x squared, no? And negative 1 squared, positive 1, and this is squared. Amazing. This expression is exactly the same of this. So this you testing is symmetric. So one, the thing I try to illustrate now is the utilization of the function notation. No? Function notation is very useful because you see another point of view of the function. Symmetry, after we discussing translation, we discussing another thing. The classical example in the test is one formula, guys, que we study in calculus, the student can need to take calculus, que es called difference of quotient. What is the formula? It's a formula like that. F in x plus h minus f of x divided by h. Okay? This is different quotient. This is the formula, and the formula is defined. That way, you can see in calculus. And this is like an application for the function notation. Suppose que f of x is given. Suppose que es x squared minus 5x plus 6. Yeah, I need to compute on this function, this different question. Let's do it. It's a classical question in the test. One question, I promise, que es compute different question. Entonces, sometimes it's easy, sometimes no, but I put it easy like that, similar to this problem, no? So, step one, you compute that part of the formula. Look. And that part is f x plus h is equal x plus h squared minus 5 x plus h plus 6. Do you see what I'm doing? Replace x for x plus h. And leave it like that? No, of course no. I expand this x plus h times itself is FOIL x squared plus xh plus xh again plus h squared. I did that part. Minus 5x minus 5h plus 6. Done. The only thing I did was that part. Step 2. Step 2 is subtraction. This guy, I computed before, minus the original. Look at the original, Entonces, I copy again. X squared. By the way, this is twice. Combine like term. 2xh plus h squared minus 5x minus 5h plus 6 minus this guy. It's minus x squared plus 5x minus 6. Do you understand why the reason I change the sign? Because it's minus this. And this minus in the front, change the sign completely, this function. Ah, wait. This is canceled. Look, a lot of people cancel in this step 2. This is canceled, and this is canceled. And stay alive only 2xh plus h squared minus 5h, and that's it, no? Yeah. Okay, finally, divided by h, according to the formula, no? Look at that. I did that part. Now divided by h. The step 3 gets the last one. Is you take this expression, okay, is 2xh plus h squared minus 5h divided by h. But this is easy because you have polynomial divided by monomial, so you divide one by one separately. Entonces, this is cancelled. This is 2x, stay only. Minus h, only one, because we have one here cancel out, and this cancel completely minus 5. Finals. Different question application. Do you understand, or is confusing? Do you understand, or is confusing? One more example or no? Kinda confusing. Okay, I understand. Okay. Let's do it one more. Easy. Now maybe you get the idea. A lot of H, yes. A lot of H, yes. Okay, let's do another more, okay, in my opinion, is easier problem. Suppose one function is given 2x plus 3. And the question say compute. Different question. And different question formula say g x plus h minus g of x, get the original, divided by h. Step 1, step 1 is replace x for x plus h. Entonces 2x plus h plus 3, sorry. This is equivalent, distribute the property here, 2x plus 2h plus 3. That part was that part. Now minus the original, entonces 2x plus 2h plus 3 minus the original, que es minus 2x minus 3. So you change the sign, no? This minus affect everything, and this is cancelled, and this is cancelled. Wow. And I stay only 2h. And finally, divided by h. 2h divided by h, the answer is 2. Entonces, let me take advantage to explain something. The different quotient idea behind different quotient is like a slope of the line, que es 2. I suppose you remember y equal mx plus b, no? And m represent the slope. In this case, it's a coincidence with the slope because it's a linear function. Pero si es quadratic function, no es slope, because si es quadratic function, it's a slope also, but a slope in between 2 points. Okay, this is the idea behind the different quotient. Guys, don't worry. I promise that in the review package, we go over again 2 different quotients. In the review package, I try to discussing problem very similar to the test, right? Different number, of course, but it's the same objective. Okay, any question about different quotients? An application? Want to know? Let's see another application of the function notation, no? Is, for example, another application of the function notation is determine the intercept using function notation. See, I ask you, for example, what is the formula to find the intersecting of any curve? Well, Professor, I don't remember very well what's the formula. I never see the formula, no? Okay, yes, we have a formula. We have the formula. The formula is easy. Look, the formula is, suppose you want to find y in a set. Y in a set, by definition, is the point, or the points, maybe it's more than 2, the graph of the curve crosses the y-axis. And the formula is the function evaluating 0. That's it. And x in a set is the point when the graph of the curve crosses the x-axis. And the formula is f of x equal to 0. Of course, you convert to equation, and this equation, you solve this equation. Okay, suppose I want to find the intercept of the parabola. Well, the parabola is ax squared plus bx plus c, no? Equal y. It's a function. But when you are doing that, ax squared plus bx plus c equal to 0, the thing we are doing is, when you solve this quadratic equation, the thing we are doing is try to find the x in a set of the parabola. It's the point. And remember, we have maybe 2 solutions, or 1 solution or no solution, because when there's no solution, it's because it's complex. But the thing we try to find is the real solution of the quadratic equation, is the yx intercept. Okay, let's see one example of this. Suppose a function, let me call h of x. It's a name, remember this h represents a name, absolute value x plus a. Okay, it's a function. Entonces my goal, what is my goal? My goal is find y in a set and x in a set. Okay, remember the formula, evaluate in 0. Absolute value 0 plus 8 is absolute value 8, absolute value 8 is 8. Therefore, the point, que es el y in a set, is the point 0, 8. Super, this is a y in a set. And the x in a set, the formula is equal to 0. And this is absolute value x plus 8 equal to 0. So we have in front of the one equation that contains absolute value, but we have only one solution, remember. On its right-hand side is 0, one solution. And you remove the bar, and x is equal to minus 8. Therefore, it's minus 8,0. Okay. Entonces, si you are doing the graph, the graph look like that. Let me show you. We have one y in a set que es en 8. 1, 2, 3, 4, 5, 6, 7, 8. That point, este point 0,8, ¿no? And we have one x in a second negative 8. In that direction, 1, 2, 3, 4, 5, 6, 7, negative 8,0. I suppose the graph look like that. Because actual value always look like a B. Okay. Okay. To relax a little bit in the last 10 minutes, I want to introduce a little bit with the Desmos. Desmos. Do you hear about Desmos? I know que some students here, Andreina. Okay. Andreina is love Desmos. Okay, guys, answer me. Do you see before Desmos or no? Align? Yes, yes, align. Did everyone saw Desmos before or never? Yes, Desmos is great. Okay. Bueno, okay. Listen to me. No, okay, Frank say, no, Frank is a smart guy. He said, no. I want to show you, Frank. Exciting. Nope. Banks, amazing. He said, nope. Okay. Desmos, what is Desmos? Desmos is a graphic calculator. But the thing is, it's free, no money, totally free, and it's online. Okay, I want to show you now, no? It's online, but online means that you, for example, you create an account similar to the Alex, you create an account using, username and password. And the work we are doing in this graphic, you can save in the cloud, and the server cloud, forever for you. And you organize in your own way. It's really amazing. What is the thing that you see beautiful and free in this country? Nothing, right? And Desmos is the only thing. It is free and useful because we can use it in any class, in any test. Entonces, for example, the graphic we are doing, you can do it in the piece of paper and take a picture, but no. I want to show you that you are doing in Desmos, and you save like one image, this graph, and send me back attached with the test. Okay, let me show you. I want to open Internet Explorer. Okay, let me see. Internet Explorer. Sorry. Internet Explorer. Okay. And open Desmos. I want to share the screen now, guys. There you go. Okay, I open. Let me share the screen. You see. Okay. I go to Skype. I try to switch in the. Okay, look at that. Okay, I go to my browser. I put www.desmos.com. Desmos.com. You click here, and you see graphic calculator. Ooh, and you open that. And Desmos, because I work frequently with the Desmos recognize me and put my name Jorge. No, in your case, you need to create accounts. You instead of Jorge. Do you see or no? Sorry, guys. Do you see the? Let me see. Switching Desmos. Okay. Yes. Do you see, right? Okay. This is me. This is my account. When you create your account, you see your name, maybe. Okay. So let's do it quickly. Something, for example, the function that we working before was g of x. Do you remember g of x? G of x is equal absolute value. Entonces, absolute value. Let me try the absolute value. I don't know how I put absolute value, but I go to the keyboard of Desmos. Look, Desmos have the own keyboard. You open the keyboard demo, you press here functions, and we have a lot of special functions. Statistic, trigonometry, miscellaneous. Let me select miscellaneous. And miscellaneous, absolute value, absolute value, no here. Absolute value is here. Look, absolute value here. Absolute value here. Absolute value what? Absolute value x plus a, no? Era plus a. Era plus a, yeah. Era plus a. And this is the graph. And we discussing also, remember, y in a set and x in a set. Look, this is the x, y in a set, 0, and this is the x in a set, negative 8,0. However, see, I want to emphasize this because default, Desmos declare what is the y in a set and x in a set. But suppose I want to represent more clear. So I press enter, I open new line, so you put the point. The point are, for example, 0, 0,8, 0,8, look, 0,8, wow, in blue color, but I want to change the color. I want to change like a red, no? Because belong to the same curve. So say, I press here, I hold the mouse, I change the color. Done, red color. Now, another point I separate by comma, if you want, no? You declare another line, you can. It's negative 8,0, negative 8,0. Boom, bada boom, bada bang. Okay, I close the keyboard, and this is my graph. You can see clear the y-intercept. We're using frequently this, okay? So my recommendation is, as soon as possible, go to Desmos, try to use in your imagination, and because frequently, next class, we are doing with the graph. If you want one more thing, and the last one. For example, if you want to save, you click here and save. But if you want several curves and you want to organize, you click here and the plus sign and create a folder. And the folder, maybe I put the name, my first graph. I complicate my life. I put graphic 1. Entonces you put it here, look, you click and drag, and now you see the connection. Click and drag, and you see the connection. And when you click here and there is arrow, boom, everything is inside the folder. And you put on enable, it's supposed I try to open another folder here. Okay? If you want to see this, click here, put enable, and you see the graph. Amazing. Okay? Okay? 10 years ago, we have not these tools. And we need to buy sophisticated graphic calculator, Texas Instrument, okay, the price is $100 something. Now it's totally free, beautiful, in color. You can save your work. You click here the name and put save. Suppose that this is the answer in your test, and you want to share with me. Okay, share graph. Boom, and you export image. Wow, and this is the image. And you have different size, medium, large, small, something, and you download the picture and send me back. Okay? What is that? Are you there? Okay. Meeting with Jorge. Okay, guys. Too much. I know it's super intense in our class. Sorry, it's not my fault. I try to do my best. Okay, entonces, as soon as possible, everyone sign in Alex and start working with the homework 1 and homework 2. Any question? I am working for you 24 hours, 7 days a week. Okay? Any question? No? No question? No. Okay, entonces I'm leaving because I have another class right now. Okay. Take care.